Welcome to the demonstration of our FinTech fraud detection pipeline. So to guarantee our architecture is reproducible and scalable and also isolated, so the entire system is containerized using Docker. And let's run all the Docker compose, all the containers. And as you can see, all the containers are up now. And let's see whether those are running. Yes, as you can see, all are running. And this is Python script for generating data. And here there is a possibility of less than zero point 0.1 to create some fraud data. And so we coded the script to generate some fraud data in this system. Let's see how it shows. And as you can see, it says send to Kafka and user ID, timestamp, merchant, category. All those details are sent to the Kafka. So those transactions are being instantly captured by Apache Kafka. So Kafka acts as a high velocity message broker for our pipeline. So it's storing raw sensor data, raw transaction data as immutable event logs to prevent data loss. Let's move into our Spark streaming script. So in here, let's first look at the speed layer code. So first we define strict schema for our incoming JSON payloads. And then using Spark read stream, we connect directly to our Kafka broker and subscribe to the transaction topic. This pulls the raw streaming data into Spark and passes it into structured columns. Next, we apply our anomaly detection rules. The first rule is the high value check. This is straightforward. So we simply filter the data stream for any transaction amount greater than 5,000 and tag it as a high value fraud alert. Second rule is impossible travel check, which is more complex. Here we use event time processing. We apply 10-minute watermark safety handle to late arriving network data without overflowing the memory. We then group data into a sliding 10-minute window per user. And if a single user has transaction from more than one distinct location, with that window, we flag it as an impossible travel fraud. Finally, we need to sync these alerts. So we define customs for each batch function in every 60 seconds, and Spark triggers these functions and appends them directly into our PostgreSQL database using JDBC. And the await any termination command ensure these teams run continuously 24/7. So these are the Spark UI. So as you can see, there's one worker, and this is Spark master, and also this is Spark worker. So let's look at the batch ETL script. So first, Spark extract the complete historical transaction from Kafka logs, and simultaneously loads and recorded fraud alerts from PostgreSQL, right? So the important logic is here, and we use left-handed join to compare the raw data against the fraud alerts. This automatically filter out the anomalies and leaving us with the only 100% validated safe transaction. And finally, we write these clean transactions into our data warehouse. We use Paracut file format because its columnar structure is highly complex and perfect for long-term analytic storage. Finally, we generate a report with this script. We create a report. This is our DAG file, and as you can see, it is running every 6 hours. So it will generate a report, so reconciliation report in each 6 hours. So this is our Airflow DAG UI. So as you can see, we already run some manual process reconciliation batch process, and you can see the PDF report is already generated. So this is what happened using Airflow DAG, and also it is scheduled to next run at 6 a.m. on May 10th. And finally, we can get those reconciliation reports. So as you can see, there is how many transactions happen, and also total ingress amount and validate safe amount, and also block fraud amount also there. And also we can get fraud attempts by different merchant categories. So in here, we can see the travel, online subscription, dining, groceries, retail, all are providing some fraud transactions. So that's the project. Thank you.